Hello, and welcome back to the awesome tutorial showing you how to make a NodeJS WebSocket server from complete scratch without any external dependencies. So anyways, in the last tutorial, we talked about the general summary for this, which is essentially the bytes needed to write to our file. And hopefully this tutorial we get to the actual writing of the code for encoding. So I did start another tutorial to do it, but then the video cut out in the middle, so I might have to just restart it because I can't figure out any video editing for WebM video formats. If anyone has an idea for that, then just let me know. So anyway, we left off last time with the handshake. Now let's get to the actual encoding, where we encode the data here. And notice that we write it to the socket, but we don't end the connection. Unlike HTTP, we end it, but the WebSockets never end, they keep going. So the first step to do is to get the length of our string, which we're going to be writing. In this case, we're just going to write text. You can also write binary, but it's not so hard to do binary. But for now, we're just going to do write text. So the first step is to get the length of our string, which is the byte length of our. Actually, we'll call it the length of our payload, which is our string, because we're going to see why in a few seconds. So, and we need to get the byte length of it. So buffer dot byte length. It's possible for each character to have more than one byte. So we need to get the byte length of our string, which it divides. A buffer is essentially an array of bytes, numbers from 0 to 256, non-inclusive. And we use that to send our data, basically. So again, so the first bit that needs to be written is fin, which determines if it's finished or not. And then we described what these were last time, the three reserved the bits, which are just 0 usually, and then the opcode, which is a code number between 0 and 16, which tells us what type of data to send. And we're just going to send text data, so we're going to put that as 1. So we're going to write that entire byte. So before we do that, we need to determine the total length of a buffer we're going to write to. So the length at least is this first byte, because that's the first header information. And then there's the second byte, which includes whether or not it's a mask. In this case, it's going to be 0. And then our payload length, which is really not our payload length if our whole payload is more than 125 bytes. But this is basically, so either we add just this, and then we add the payload length from here, and we skip the masking key because it's 0. Or if the payload length again is what, as I mentioned last time, if it's exactly 126, then we need to add 2 additional bytes. And if it's exactly equal to 127, then we need to add 8 additional bytes. So either we need to add 0 additional bytes besides for these 2 bytes, or we need to add 2 additional bytes for here, or we need to add 8 additional bytes depending on the length of the payload data. So that's what we're going to do. So we need to know like how many bytes to add. So just to simplify things, let's just make it if scenario. So if our length of payloads is less than 126, which is between 10 and 125 inclusive, then we need to add 0 bytes. So this is equal to 0. But if our length is more, if our length of payload is more than it, if it's more than 126, but if it's there's another condition though. If it's more than 126 bits, but still less than 16 bits, then we need to add a 2. But if the length is a 64-bit number, then we need to add 8, as it says in the documentation here. It says if, yeah, so, okay. Yeah, it's basically it says it somewhere. The point is, we so if it's greater than 126, but if it's still less than 16 bits, a 16-bit number, which is 2 to the power of 16. So what did I say? Okay, no. Else, but if it's more than 125, but it's still less than 2 to the power of 16, which is 16 bits. If it's more than 125, which is already included else, and if it's still less length of payload, if it's still less than 2 to the power of 16, then we need to add 2 additional bytes equals 2. And if it's greater than that, but still less than 2 to the power of 64, then we need to add 8 additional bytes. Else, if length of payload is less than math.pow 2 to 64, then we need to add 8. And if it's more than a 64-bit number, meaning if the length of the payload is more than a 64-bit number, which is a huge amount, then we're just going to return and close the connection. Else, return. Or just not send anything. Or we can just send... Actually, let's just like send something. No. Okay, no, we have to just return. Or, yeah, okay, we just have to... No, or... Okay, we'll just... You know what? We'll just return for now. Maybe like we'll console.log something too big. Okay. Now we have the length that we need to actually determine, but now we actually have to make. This is okay. This is playing in the background, but whatever. This is the earlier video that I made, but didn't really work. Okay. Anyway, now let's actually make the buffer. So to do that, this is the buffer that we're going to actually send. So buffer to send, and the way to do it, we say buffer.alloc with the length amount. So first of all, the length amount is the first 2 bytes up to here, and here, plus the number of additional bytes we need to add, plus the payload length. So 2 plus how many bytes to add, plus length of payload. Now we need to actually just write the bytes. So the first byte should be pretty easy because, again, the fin bits in this first byte is going to be a 1 in this case because it represents fin is sort of finished, which means we only write this if it's the last bit, if it's the last message in the cycle, because it's possible to send multiple messages at once. This is okay. I don't know why this keeps playing. This mimer wants to keep talking, but it is causing some latency issues. Whatever. Anyway. Point is, we write this bit as 1, and then the rest of it is 0, except for this opcode, which is now a number between 0 and 16, but in this case, we're just going to make it 1. So, because it's a text type. So, to do that, it's very simple. So, we're going to write a uint buffer to send dot write uint 8, which is essentially a fancy way of saying to write a byte, which is numbers between 0 and 256 in binary format. And it could be just a number, but just to make things simpler, I'm going to write it in binary format. So to do that, to follow along, you do 0b, which means we're going to write in binary. Then we just write the byte directly using zeros and ones, which is kind of cool. So first, the first bit is 1, which represents if it's the last frame, meaning if it's the last message in the cycle. And since from the server to the client, we're just going to send 1 message total. It's possible to fragment them into different sections, but it's very complicated. So we're just going to do the first message is the last one, so that's 1. And then 3 reserved bits, as mentioned. And then the 16-bit number, which is, in this case, we're just going to equal to 1 because it represents the type, and the type in this case is text. So 1, 2, 3, 1, which this essentially 16-bit number, but we have to have the zeros there, and it's equal to 1. And the offset, we have to make an offset of where to write it, because a buffer is essentially an array of bytes. But when we write to it, we have to tell it where in the buffer to write, because it's pretty big. It's this big, and we don't know where to write to it. So we have to make a new offset equals 0, and then the offset, and we can actually add the offset by 1. This is a little complicated, whatever. There's just to simplify things. Now the offset is 1. You don't really have to do this, but this is just like to follow along. Meaning we're writing at the first we wrote at the 0th byte, which is the first byte. Now we're writing at the 1th byte, which is really the second byte, which is from mask. So the first bit represents if it's a mask or not, and if it isn't, if we are masking it, then we have to combine bits because we have to have this payload length. But since in this case we're not going to mask it, which masking is the encoding as mentioned, this is going to be 0, and if the payload length is less than 126, then we just write it, and then automatically it's a list of 7 ones, and it leaves the first one as 0 anyway. So that's what we're gonna. So we have to do some serious if statements, because we'll just say again, if our length is less than 126, then this here is what is the length, and we make that the length. So if the length of our payload is less than 126, then what we write buffer to send, we're just going to retype it. So buffer to send dot write uint 8. Then we write the actual length itself because it's less than 126, and then it'll just be at most a bunch of ones with, except for the last, it'll be about, I think six, five. It'll be 5 ones and then 0 1 at most. And that's 125. But then if it's, and then at the offset is here. And the mask, in this case, this bit is going to be 0. And since the payload length is only 7 bits, it's going to leave this 0 automatically. But then if the length of the payload is, again, is less than 2 to the power of 16, which is 16 bits, meaning if it's greater than 125 but still less than 16 bits, math.power, we could just save it as variable, but just for simplicity, 2 to the power of 16, which is 16 bits. If it's greater than 125 but still less than this, then we need to write the exact number of 126, because that's just the code that they decided to make it if it's that. Buffer to send dot write uint 8, and we're just going to write it in binary format just to make it fancy, because we can. 0b, and then since the first bit is the mask, which is 0, so 0, and then 126 is essentially 6 ones. No, yep, six ones and then a 0. So 1, 2, 3, 4, 5, 6, 0. And this is why, I'm just showing you this to show you why they made it where the last number of making it 126, 127 is that, because these are the last two numbers that are possible to fit in here. 126, then 127 is the next one, which is the last possible thing to fit. So now, and then we need to do that at our offset, which is 1. And then if the length of payload is greater than 16 bits, but still less than 64 bits, math.pow to 64, then we need to write this number 127, which is essentially a one with 7 ones, and then the 0 for determining if we're masking. In this case, it's 0 because we're not. So buffer to send dot write uint 8. So again, byte format, and then the first bit is this mask. So are we going to encrypt it? Are we not going to encrypt it? When we're sending it from the server to the client, we don't need to encrypt it. But when the client sends it to us, then it is encrypted, which is more complicated, but that's another issue. Point is, when we're sending it, we're not going to mask it. We're not going to encrypt it. So 0. We're not going to mask it. And then we need to write the number 127, which is 7 ones. 1, 2, 3, 4, 5, 6, 7. And that's at our offset. Now, we should also probably make a variable. Yeah, okay. We should. Okay, we need to change the offset in a second. So essentially, if the payload length is less than 126, then our current byte offset that we're going to write at is the byte right after this, which is 2, which is the third byte, which starts from here. So then from here, we write our payload data, meaning we skip the masking key because we're not masking. So this is not even here there at all. And then this extended payload length is not there at all. And also this is not there. So if it's less than 126, then right after that, in the third byte, in the index 2, then we put our payload data right away. So then our offset is left off at the third byte, which is 2, because it starts at 0. So that's if it's less than 126. But if it's between 126 and and um and a 16 and 16 2 to the power of 16, then we need to our byte offset is an additional 2 bytes, meaning again if the payload length is more than 125 but still less than 2 to the power of 16, then we need to write this here. So then our payload length is going to start directly after that, which is going to start here, and this is not going to be here. So then our payload length, which is shown as here, is going to be instead start here right after the first extended payload length. And then if our payload length is greater than 2 to the power of 16 but still less than 2 to the power of 64, then it's going to extend all the way to here, and our byte length is going to need to add 8, which is going to start at here, which essentially I can't even count what it is. But we need to add from where we are. We need to add 8. But if in this case, if we just need to add 2, so meaning the offset, meaning this is where we're going to write our actual payload. So in this case, once we write the length of the payload, our offset is 2 because we're going to write the payload here. But in this case, where it's between 2 to the power of 16 and 2 to the power of 64, our offset is going to extend to the 4th byte. So no, to the 5th byte, 0, 1, 2, 3, 4, which is number 4, but it's the 5th byte. So the offset equals 4. 2 plus 2. Then if our number is between 2 to the power of 16, no, earlier I think I messed up. This case is saying if it's less than 2 to the power of 16. But if it's in between 2 to the power of 16 and in between 2 to the power of 64, then we need to add an additional 8 bytes besides for 2. So 2 plus 8 is 10. So offset equals 10. Hopefully that's correct, because it would normally be 2, meaning at the 3rd byte, which is here. But since we need to add 8, that's 2 plus 8, which is here. So pretty sure this is right. Hopefully. Let me just... I could... Just checking. I don't even know what... Oh, okay, plus equal. If it started at 2, then plus equal 2 plus equals 8, it's 10. Okay, nice. And now after this, all we have to do is just write the payload. And then that is pretty much it. It's very simple. I thought it would be a lot more complicated when I first started. But this is how to make an entire socket server just to send from the server to the client. To read is another issue, but we'll get that